Ito ang 106.3 Dance Radio. Dance Radio.
Prepare yourself.
Ang silid-aralan sa radyo, hatid namin ay makabagong paraan ng pagtuturo at kalaman. Mapaumaga, tanghali o hapon man yan. Ang istasyong magbibigay impormasyon kahit saan man.
For something big. Alright, here we go.
106.3 Dance Radio. Doña Aurora National High School, Santa Rita, Aurora, Isabela.
This
106.3 DWDR-FM. Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is the way of helping the brain grow in finding new knowledge and help us defeat our curiosity and how the world develops and works today. Science. This is your class, and this is science. And now, here is your host for the day.
Okay, good afternoon. Magandang hapon po sa ating mga listeners and viewers. Most especially sa ating mga grade 9 learners. So, welcome mga anak. This is another fun-filled experience while watching and listening to our radio-based instruction. Ayan. Hello, Ma'am Dina. Okay, batiin mo na ang ating mga listeners.
So, thank you, Ma'am Jen. So, good afternoon once again, dear learners, especially the grade 9 learners. So, ito na naman tayo ang aming pagbabalik talaga, di ba? Kasi weekly kami nandito, di ba? Okay, so sana naka-tune in na tayong lahat, mga learners, grade 9. Hindi ko na kayo isa-isahin, basta lahat ng grade 9 learners. Kasi lahat naman tayo may science, di ba? Sa BEC, sa SSC, or the Special Science Curriculum, ating SPJ, grade 9 SPJ, and grade 9 SPA. Magandang tanghali sa ating lahat.
Yes, syempre ma'am, hindi natin kakalimutan ng ating mga admin, ano? So magandang hapon po sa ating Municipal Mayor, Mayor Christian Jiwi, and to our fatherly OIC, our Sir Rodrigo B. Pascua, to our Assistant Principal, Ma'am Ruby Guillermo, and to all head teachers, the dance faculty, and to all, syempre ma'am, yung mga parents na taga-suporta rin natin. Ayan, magandang hapon po. Welcome to another episode of Scientific Time in Grade 9. Ma'am, ano ba ang ating pag-aaralan for this afternoon?
Okay, yes, Ma'am Jen. So, ang topic natin this afternoon is all about the different types of compounds. O, yan po. So, napakalawak ng ating lesson ngayong week na ito, the different types of compounds. And we all know that the types of compounds nandyan lang. Lagi natin nakikita, nandyan lang nakapaligid sa atin. Okay, so for today's live airing of lessons objectives, we have two. Number one, to differentiate ionic from covalent compounds. And number two, to describe the different properties of ionic and covalent compounds. So yan yung objective natin sa ating airing ng lesson natin for this week, Ma'am Jen.
Okay, so get ready, ating grade 9 learners. Dapat meron kayong hawak na pen and notebook at inyong last para sa masundan nyo kami sa ating airing for this afternoon. Okay, so without further ado, this is our RBI lesson for this week.
Radio, silid-aralan sa Wala nang makakapigil pa. Sulong Arangkada 106.3 Dance Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta't magtulong-tulong, sulong edukalidad, Dance Radio. Learning is amazing.
Physics, chemistry, earth science, biology, biochemistry, environmental science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is a way of helping the brain grow in finding new knowledge and help us defeat our curiosity of how the world develops and works today. Science, science, science. This is your class, and this is science.
Good day, my dear grade 9 learners. How are you?
I'm fine, I'm fine, I'm fine, thank you.
Welcome to the RBI session in Science 9. Please get your learning activity sheets number 2 titled Types of Compounds. I am teacher Ryufei B. Magaway, your radio teacher in science. I will be with you until we finish our lesson. Are you ready?
Yes, ma'am.
Before we start, let us have a review about our topic last week. Let us see if you have listened attentively. Who can share their learnings they had last week?
Ma'am, we learned that electron configuration describes how electrons are arranged in successive sublevels and orbitals.
Very good! What else?
We also learned about the 3 rules or principles in writing the electron configuration of elements, which are Aufbau principle, Polis exclusion principle, and the Hands rule, ma'am.
You are right! What are the differences implied by these 3 rules?
The Aufbau principle states that electrons occupy the lowest energy level before feeling higher energy level, ma'am.
Correct! How about the Polis exclusion principle?
Polis exclusion principle states that no more than 2 electrons can occupy the same orbital, and 2 electrons in the same orbital must have opposite spins, ma'am.
You are right! How about Hands rule?
Hands rule states that a single electron with the same spin must occupy each orbital in a sublevel before they pair up with an electron with an opposite spin, ma'am.
Very good! You really understood the previous lesson. In this episode, you are expected to, number 1, differentiate covalent from ionic compounds, and number 2, describe the different properties of ionic and covalent compounds. Have you ever tried to place side by side a transparent container of salt and a transparent container of sugar without even any labels?
Yes, ma'am. They look almost the same, ma'am.
You are right! There is a wide variety of compounds, and most of these look physically the same, like sugar and salt. How do you differentiate one from the other?
It would be easier to determine these 2 substances by testing them, but this method does not apply to other compounds since some of them can be toxic, ma'am.
Yes, that's right! Many compounds are toxic. That's why it is not advisable to taste.
Aha!
Okay, let's start by defining the term compound, dear learners. Who can do it?
Compound is a chemical substance composed of many identical molecules or molecular entities composed of atoms from more than one element held together by chemical bond, ma'am.
You are right. How about a chemical bond?
Chemical bond is a force that holds atoms together to make compounds or molecules, ma'am.
Correct. Compounds can be formed between the chemical combination of two or more elements. There are two types of compounds based on their bonding characteristics. What are these?
The two types of compounds are ionic and covalent compounds, ma'am.
Very good. Who can describe an ionic compound?
Ma'am, ionic compound is a compound that is formed by ionic bonding. Ionic bonding occurs through a process called electron transfer, where one atom gives electrons to another, ma'am. Ionic compound is formed from the combination of a metal and a non-metal, ma'am.
That's right. In electron transfer, an atom of one element loses one or more electrons, and an atom of another element gains those electrons. Who can give an example of an ionic compound?
Example of ionic compound is sodium chloride or NaCl, ma'am.
You are right. Sodium is a metal combined with chlorine, a non-metal. What other example can you give?
Another example is potassium oxide or K2O, ma'am.
Very good. How about covalent compound? How is it formed?
Covalent compound is formed from the combination of two non-metallic elements or a metalloid and a non-metallic element, ma'am.
Correct. Can you give an example of covalent compound?
An example of covalent compound is water. It is the combination of hydrogen and oxygen atoms, ma'am.
Very good. Hydrogen and oxygen atoms share electrons to form the water molecule. These sharing of electrons result in a covalent bond between atoms. Who can give another example of covalent compound?
Another example of covalent compound is oxygen gas molecule, ma'am.
That's right. There are two types of covalent compounds. What are they?
The two types of covalent compounds are polar and non-polar covalent compound, ma'am.
You are right. How do we distinguish polar from non-polar covalent compound?
In polar covalent, the electrons are shared unequally by the atoms because they are more attracted to one nucleus than the other, while in non-polar covalent compound, the electrons are shared equally between two atoms of the same elements or between two different elements, ma'am.
Great! Who can give an example of polar covalent compound?
An example of polar covalent compound is water or H2O, ma'am.
Correct. How about an example of non-polar covalent compound?
An example of non-polar covalent compound is the molecular nitrogen, ma'am. The electrons are equally distributed between two nitrogen atoms.
You're correct. We continue our discussion after an infomercial.
COVID-19 has caused loss of lives and economic hardship all over the world. It has changed our habits and the way we live while testing our public health systems and impacting on our livelihoods. With this, the role of environmental health practitioner has never been more vital as we face up to the ongoing challenges this pandemic. Many changes are about to happen for a greener environment, more equal and more stabilized economy. COVID-19 pandemic has resulted numerous impacts on the environment and climate. But amid this crisis, we have a chance to build a better community and environment. Hashtag healthy environment. Hashtag healthy community.
It's science time!
You're listening to Teacher Rio.
I'm back. Let's continue. Ionic and covalent compounds can also be described or recognized based on their properties. Who can give and describe one property of ionic and covalent compounds?
The first property of compound is hardness, ma'am. Hardness is the ability of material to resist deformation. Ionic compounds tends to be hard and brittle and may exist only as solid at room temperature, while covalent compound tends to be softer and flexible and may exist as solid, a liquid, or a gas at room temperature, ma'am.
Very good! The strong forces in ionic compounds allow them to form crystals, which make them harder than covalent compounds. What other property that you know, dear learners?
Ma'am, another property is melting point. Melting point is the temperature at which the solid and liquid forms of a pure substance can exist in equilibrium. The strongest bond in crystalline structure of ionic compound requires high energy to change its solid phase into liquid phase, resulting to higher melting point of ionic compound than covalent compound, ma'am.
That's great! The melting point of ionic compound is higher than covalent compound because of the strong electrostatic forces of attraction between oppositely charged ions. How about their solubility? Who can describe the solubility of ionic and covalent compounds?
Ionic compounds are more soluble in water than covalent compounds, ma'am.
You're correct! Covalent compounds can be classified into polar covalent, which can only be dissolved in a polar solvent, and non-polar covalent can only be dissolved in a non-polar solvent. How about their conductivity property?
Ionic compounds conduct electricity when in solution but not in solid phase, while covalent compounds are non-conductors of electricity both in solid and in liquid phases, ma'am.
Very good! Solid ionic compounds do not conduct electricity because there are no free mobile ions or electrons. Covalent compounds do not have ions, hence, they do not conduct electricity.
Aha!
To further understand the lesson, let's answer the given questions found in your learning activity sheets. Okay, are you ready?
Yes, ma'am.
In Activity 1, titled Ionic or Covalent Compound, tell whether the compounds found in column 1 are ionic, polar covalent, or non-polar covalent. Write your answer on a separate sheet of paper. Number 1. What type of compound is iodine gas molecule? I repeat, what type of compound is iodine gas molecule?
Iodine gas molecule or I2 is a non-polar covalent compound, ma'am.
Very good. Number 2. Potassium chloride is what type of compound? I repeat, potassium chloride is what type of compound?
Potassium chloride is an ionic compound, ma'am.
You're correct. Please answer the remaining items after this airing or in your most convenient time. Let's proceed to activity number 2, titled Properties of Some Compounds. Directions. Study and analyze the given properties of some compounds on page 3 of your learning activity sheets. Then answer the following questions. Number 1. What type of compound is formed when two atoms that belong to the same group are combined with each other? I repeat, what type of compound is formed when two atoms that belong to the same group are combined with each other?
The compound formed is a nonpolar covalent compound, ma'am.
Very good! Can you formulate a general statement about the properties of ionic and covalent compounds?
Ma'am, Ionic compounds are soluble in water, have high melting point, and conduct electricity in solution. Covalent compounds are insoluble in water, have low melting point, and do not conduct electricity both in aqueous and solid forms.
Very good! Now, who can sum up our topic today, my dear learners?
To sum up what we have learned today, compound is a chemical substance composed of many identical molecules or molecular entities composed of atoms from more than one element held together by chemical bonds, ma'am.
You're right! Who can differentiate ionic from covalent compounds?
Ionic compounds are formed when an element gives away its electrons to another element. It is a combination of metal and a non-metal, while covalent compounds are formed when elements share electrons. It is a combination of non-metal and another non-metal, ma'am.
Correct! What more have you learned, dear learners?
We've learned about the different properties of ionic and covalent compounds such as hardness, melting point, solubility, and conductivity, ma'am.
Very good! In order to measure your understanding, please answer the following questions.
How are ionic and covalent compounds formed?
Ionic compounds are formed when a metal reacts with a non-metal, while covalent compounds are formed when two non-metals react with each other, ma'am.
Between ionic and covalent compound, ionic is characterized by transferring of electrons while covalent compound is characterized by sharing of electrons, ma'am.
Great job! Are ionic and covalent compounds important in everyday living, dear learners?
Yes, ma'am. It is very important to us. Scientists formulated products which all of us consumers use in our everyday living. For ionic compounds, we have sodium hypochlorite or the chlorine bleach used to remove stains in clothes, hydrochloric acid or muriatic acid in removing tough dirt in toilet bowls and tiles.
Furthermore, some are sodium fluoride or the fluoride in our toothpaste, and calcium carbonate, the ingredient of antacid in medicines we take when we have gastritis. For covalent compounds, the carbon dioxide is used in soft and cold drinks, and hydrogen monoxide is present in water we drink every day, ma'am.
Great idea! I guess you have got a lot of learnings today. We're done with the lesson. I would like to acknowledge the teachers behind this School on the Air lesson. Ma'am Fernandina C. Benito, our script writer. Ma'am Rosabel R. Brillo, our language editor. Sir Ronnie G. Abalos and Ma'am Annabel A. Rodriguez, our content editors. Ma'am Riza N. Marzan, our technical specialist. And I am Teacher Rio Faye B. Magaway, your radio teacher in science. Thank you very much for listening. Goodbye and have a good day, everyone.
Dance Radio, siniparalan sa radyo. Hatid namin makabago, paraan ang pagtuturo.
Wala nang makakapigil pa. Sulong Arangkada 106.3 Dance Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta na magtulong-tulong. Sulong edukalidad, Dance Radio. Learning is amazing.
Physics, chemistry, earth science, biology, biochemistry, environmental science, These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is a way of helping the brain grow in finding new knowledge and help us defeat our curiosity of how the world develops and works today. Science, science, science. This is your class, and this is science.
Okay, so we're back. Okay, so thank you for listening sa RBI natin or sa airing of our lesson. Okay, so for our live streaming or for our live discussion today, we have Sir Ronnie Avalos, Ma'am Donabel Velasco, of course, Ma'am Jennifer Lacambra, and of course, ako, si Ma'am Dina. Okay, so dun sa ano natin, so we have different objective from the RBI lesson or dun sa lesson natin na i-air kanina sa live discussion natin. So in our live discussion, meron din tayong 3 objectives to attain. Okay, so makinig tayo mabuti na, mga dear learners natin. Okay, so number 1, we're going to determine the location of the metal, the non-metal, or metalloids in the periodic table. Kasi the location alone of the elements, or the position of the elements in the periodic table, whether a metal, a non-metal, or a metalloid, we can already use that to identify or to determine what type of compound is being formed. So, kailangan alam natin nasaan kaya yung mga metals, mga non-metals, and metalloids. Okay, then the second one, use the electronegativity difference in determining the type of compound. So, dun sa there are okay, so use the electronegativity difference. Use the electronegativity difference in determining the type of compound form. So, kung mapapansin natin, if you have your periodic table, yung commercial one, or dyan sa mismong last natin, I think, meron tayong periodic table yan. So, may mga electronegativity values yan. So, yun din pwede natin gamitin. Yun yung mga i-discuss. Then, the last one, identify compounds used in our daily lives. Ano ba yung mga, kasi di ba sabi ko nga kanina, marami tayong mga compounds, nagkalat ang mga compounds na nakakatulong. Maraming mga uses sa atin. Okay, so Ma'am Jen, yun yung ating mga objectives for our live discussion.
Yes, ma'am. Ayan. So, let's start. So, we have types of compounds. Yun. Sabi nga ni ma'am kanina, compounds are everywhere. Ayan. Okay. So, let us look at the periodic table of elements. So, we have here metals appear to the left of the dark zigzag. So, tignan muna natin yung zigzag line. Okay. So, on the right side, ayan, makikita nyo yung zigzag line. Actually, na-discuss na nila ito, ma'am, during their grade 8 science. So,
yes,
ayan. So, we have there the metalloids. Then, on the left side of that zigzag line, we can find the metals. Ayan. So, ang daming mga metals. And most metals are solid at room temperature. Okay. Then, on the right side of the dark zigzag line on the periodic table, we have there the non-metals. Okay. So, makikita nyo dyan. Then, although hydrogen is in family number 1, okay, doon, punta tayo sa number 1, yung hydrogen.
Yung naka-red doon, ma'am.
Oo, yung naka-red.
Yes.
Okay, the element number 1, the hydrogen, is in family 1, it is also a non-metal. So, siya lang po yung naihalo dyan sa left side na non-metal. Doon talaga siya sa part ng non-metal. Okay, many non-metals are gases at room temperature. Next. Metalloids can be found clustered around the dark zigzag line that separates metals and non-metals. Okay, so Ma'am Dina, ano ba yung mga metalloids natin dyan?
Okay, so Ma'am Jen, yung mga metalloids natin dyan, yung nakadikit doon sa mismong zigzag line, yung dark zigzag line, kagaya nung si boron. Boron is a metalloid. Diba? Pag sinabi kasi nating metalloids, pwede siyang maging metal or meron sa kanya yung dalawang property na yun na pwede siyang maging metal or pwede rin siyang as a non-metal. So, an example dyan yung aluminum. Aluminum also. Okay? Aside from boron, aluminum, yun yung mga metalloids natin. So, kukunti lang yung mga metalloids natin, di ba? So, meron lang tayong 2, 4, 6, 8. 8 ba, Ma'am Jen? Okay, so we have also silicon, germanium, arsenic, antimony, tellurium, and we have polonium and astatine. So, yun lang yung mga metalloids natin. Kung ano sana natin sa tao yan, ito yung pag sa tao, di ba parang ang ginagawa ko kasi pag may face-to-face, mga metals, dinidescribe ko, sinasabi, eto yung mga totoong mga lalaki pag sa tao. Or mga totoong babae, parang ganon. Pag non-metals naman, sila yung, anong tawag natin sa kanila, ma'am, or, tama ba ako? Yes. Oh. Pag non-metals, ito yung mga lalaki. Mga non-metals, parang mga babae. Then, yung sa mga metalloids, ang sinasabi ko sa kanila, sila yung parang pwede silang maging babae, or pwede silang maging lalaki. Parang ito yung mga silahis. Tama ba ako, Ma'am Jen? Pag sa tao.
Yan. Metalloids, the properties of metalloids can be meron siyang metallic properties, meron din siyang non-metallic properties. Kumbaga, it's combination. Okay.
Yes,
So, knowing the position of the metals, non-metals and the metalloids, ayan, tignan naman natin yung isang property nila na napaka-importante in chemical bonding. Okay, we have electronegativity. So, electronegativity is a chemical property that describes the tendency of an atom or a functional group to attract electrons toward itself. Yan. Pag pag dinidiscuss ko to, usually ang sinasabi ko is, ito yung appeal mo. Kumbaga, kung maraming na-attract sa'yo, malakas ang electronegativity mo.
Yes.
Ayan. So, kagaya ng mga atoms, the higher their electronegativity, the higher their tendency to attract electrons. Okay,
So,
na-discuss last week yung ang mga electrons, kung saan nakaposition yung electrons. Ayan, andun yung valence sa shell doon, yung mga electrons sa valence shell, we call that the valence electron. They are the ones that are being attracted. Yes, yun sila yung involved sa bonding. So, yun. Electronegativity of an atom is affected by both its atomic number and the distance that its valence electrons reside from the charged nuclei. Usually, ma'am, kapag yung atomic number nila, yung atomic number magde-determine kasi na, ma'am, di ba, ng position nila.
Yes, position nila. Kasi sunod-sunod yan, Ma'am Jen, di ba? From left to right. 1, 2, 3, 4, yun yung atomic number.
Okay. Meron din dyan yung distance that the valence electron resides from the charged nuclei. Meron siyang connection sa laki or yung size nung atom, di ba, ma'am?
Yes.
Mas malaki yung atom, mas malayo, hindi laki. Mas malayo yung valence electron niya doon sa nucleus, mas mababa ang kanyang electronegativity. So, malayo na siya eh. Kumbaga kumbaga malayo siya. So, mas malayo na siya doon sa nucleus, which is doon siya na-attract eh. So, malayo na siya. So, madali na siyang mahila ng iba, aray. Ay, ganun ba?
Ganon.
Hindi naman. So, ganun lang yung point,
Parang ang ano mo dyan, Ma'am Jen, is parang LDR.
Ganun ba yun?
Oo.
Hindi, maraming LDR naman
Na
dyan na
strong.
very, okay. So, ayan. So, use electronegativity values to determine band types. Okay, pag titingnan natin doon sa ating periodic table, nandoon po yung electronegativity value. Okay, wala po siyang unit, no? Okay. So, ito yung magde-determine kung ano yung band type niya. Kung siya ba ay yung na-discuss kanina sa RBI na ionic band, kung siya ba ay polar covalent bonds, or siya ba ay non-polar covalent bond. So, makikita nyo pag susubtrakin nyo yung electronegativity nila,
Yes, ma'am.
yes, kung ang lalabas ay greater than 2.0, the band that exists is an ionic band. Kapag ito naman po ay 0.21 hanggang 1.99, it is a polar covalent band. Kung siya naman ay non-polar covalent band, the electronegativity difference is less than 0.20. Okay.
Yes, Ma'am Jen.
So, magre-range up from 0 to 0.20. Okay, tama.
0. Yes, tama.
0.0.
Ma'am Jen. 0.20. Okay, so madali lang, di ba? Huwag kayong mag-alala kasi madali lang din yung kumuha nung sum. Tama ba ako, ma'am? Oo. Kahit balik
Hindi,
yan.
difference.
Yes,
Kasi
difference.
subtraction, Subtraction.
Madali lang, nakunin yung difference kasi kahit mas mataas, mas malaki yung value nung nasa baba, yung subtrahen mo, ano pa din siya, pasok pa rin siya. Let's say for example, 1.99 or 0.21 minus 1.99, baliktarin mo lang siya, okay na siya. So madali lang dito yung pagkuha ng electronegativity difference.
Yes, ma'am. Anyway, magbibigay tayo ng example,
Yes,
ma'am. Okay, so we have here sodium chloride, NaCl, or table salt. So we have here, ano ba muna yung mga elements or yung atoms na involved? So we have sodium and chlorine. So titignan natin ano ba yung electronegativity ng sodium and chlorine. So sodium is 0.09 and chlorine is 3.0. So ipag-subtract mo yang dalawang values na yan, we have you will have 2.1 electronegativity difference. So babalikan natin yung kanina table, na hindi table. Okay, ano ba 'yon? Ulitin natin. 2.1. So tingnan nga natin saan diyan magpo-fall yung 2.1. Okay, so saan diyan, ma'am?
It is an ionic, ma'am. Ionic siya kasi yung kanyang difference is greater than tama ba ako? Yes, greater than 2.0. Kasi sabi natin, di ba? 2.0 pataas, ionic band. Yan.
Yes. Meaning, ionic band, meaning there is a transfer of electron. Alin dyan ang nag-transfer ang electron? Alin ang nag-receive? Alin ang nag-lose? Alin ang nag-receive? Ma'am Dina.
Okay. So, balikan natin yung sa ang metal kasi, they tend to lose an electron. While the non-metal, they will attract or they will gain an electron. So, yung mga metals natin and sodium is a metal. Tama ba ako, Ma'am Jen?
Metal.
Yung sodium is a metal, kaya siya yung nag-lose, siya yung nagpahingi ng kanyang electron.
Kasi mas mababa
mas
ang
ang
kanyang
kanyang
electronegativity.
So, therefore, Ma'am Jen, mas mababang electronegativity, the more na mas madali siyang magpahingi ng kanyang excess electron.
Yes. And si chlorine naman, tinanggap niya naman yung electron ni sodium.
Bakit niya tinanggap, ma'am?
Oo, kasi kailangan niyang maging stable. So, para maging stable siya, dahil may kulang sa kanya, ma'am.
Yes.
Okay.
Yes,
So, para
ma'am.
maging stable siya, it needed the extra valence electron of the valence electron of sodium.
Para parehas sila. Hindi lang si chlorine ang magiging stable dito, Ma'am Jen, di ba? Pati si sodium na nagpahingi, naging stable na din siya.
Yes, and because, madidiscuss natin mamaya, because of their charges, kaya sila nag-attract. Kaya nag-bind silang dalawa because of the positive and the negative charge nilang dalawa. Didiscuss natin mamaya ulit. Okay, second example is we have water or H2O.
Water is everywhere.
Yes.
O, diba?
So what are the involved elements or atoms in water? So we have hydrogen and oxygen. Ayan. So hydrogen has 2.0 electronegativity while oxygen ay meron namang 3.5. Get the difference? We have 1.5 electronegativity difference.
Kaya siya
Balik tayo doon sa ating table. Na hindi
kaya
masyadong
siya
table.
Polar covalent siya.
Opo.
Polar siya.
Covalent bond.
Yes, kasi yung kanyang difference is 1.5. Yes, nasa between
gitna.
0.21 and 1.99.
Okay. Yes. Meaning, since ito ay covalent bond, there is a sharing of electron. Hindi siya manghihingi. Mag-share sila. Yes. And we also have hydrogen gas. So, hydrogen gas, hindi nakalagay dyan. Okay. So, the electronegativity of hydrogen is 2. Okay, ano bang involved dyan? So, hydrogen and hydrogen, pag pinag-minus mo sila, okay, anong lalabas? 0, syempre. Okay, so, siya ay yes.
Non-polar covalent siya, Ma'am Jen.
Okay. Kasi 0 siya. So, less than 0.20. Okay.
So, nagkakaintindihan po ba tayo? So, madali lang, di ba? Using the position or metal or non-metal metalloids, alam na natin kung ano yung ma-form na type of bond. And another is yung ating electronegativity difference. I-subtract lang natin yung mga electronegativity values ng mga involved na element dun sa compound, then pwede na nating malaman kung anong type ng compound yung nabuo natin. Pero take note hindi porke metal siya, non-metal, pwede na silang mag-combine. Di ba, Ma'am Jen? Yes. Meron pa rin tayong mga doon. Hindi pwede. Parang sa tao din, hindi porke nakita mo maganda siya, gwapo siya, pwede na silang maging sila.
Kailangan mag-swak muna kayong dalawa.
Diba,
okay. What did the atom of fluorine say to the atom of sodium? Nung sabi niya, you complete me, sabi niya. Kaya tayo may sodium fluoride, yung kanina doon sa RBI natin. Okay.
Nakompleto na kasi siya.
So we have three major types of bonding. So ayan, kanina nasabi na natin we have ionic bonding which forms ionic compounds. And there is a transfer of valence electron. Metallic bonding, it exists between metals. Yes. Covalent bonding, it forms molecules molecules. Then it includes or involves sharing of valence electrons.
Hindi nila kailangang humingi at magpahingi. Magsisharean lang sila sa covalent bonding.
Ito yung sinasabi natin kanina, ma'am, na ito yun, positive and negative. Yes. So, in ionic bonding, it is always formed between metal cations and non-metal anions. The oppositely charged ions stick like magnets. So, kasi ma'am, yung mga metal, sabi mo kanina, they tend to lose electron.
Magpapahingi sila ng kanilang electron.
Okay, when they lose, they become
stable.
Yes, and become positively charged.
Yes,
sila na ay mga cation ngayon. And the nonmetals, they tend to gain electrons. When they gain, they become negatively charged. And sila na ngayon ay magiging anions. So, during our Science 8, we say positive and negative. So, opposite charges, they attract like magnets. Kaya nagbabind sila, ma'am, kasi positive, negative.
Yes.
Opposite attracts, ika nga. Hindi
Yes.
pag positive, hindi magdidikit yan.
Kahit
Hindi
anong gawin
magbabind
mo,
yan.
kahit talian mo yan, Ma'am Jen.
Oo, maghihiwalay at maghihiwalay sila. And then, ayan, kaya yung formation ng cations and anions, the positive and negative charges of the, of the ions, yan, naging compound sila. Okay. Nagsama sila daw. Okay, yun. O, yan.
Sa metallic bonding naman. Sa metallic bonding, di ba sabi natin kanina, Ma'am Jen, this occurs between two metal. Kagaya ng mga solid gold, silver, yung mga yon. Mga ano natin yata, Ma'am, mga jewelries? An example dito, Ma'am?
Yes, ma'am. If you look at the illustration, halimbawa meron kang silver ring, di ba? Silver yan, Ag.
Oo.
Okay. Ganito po ang formation ng atoms ng silver sa isang bagay. Ayan. So, yung nucleus niya and then the electrons are floating sa labas. Okay, yan yon. So, makikita natin na the electrons there are arranged outside the nucleus siya, and then nakakalat siya dyan. Ito, it makes the property of a metal malleable, kasi malleable siya. Hindi yan magbe-break kasi naka-float lang siya, pwedeng mag-rearrange yung mga electrons diyan. So, unlike the ionic compounds, na hindi ganito ang kanilang formation. Okay. Then, yan, ma'am, we have covalent bonding. Okay, so it forms molecules. Pairs of electrons are shared between two non-metal atoms to acquire the electron configuration of the noble gas. Okay. Ayan. So, occurs between non-metal atoms which need to gain electrons to get a stable octet of electrons or a filled outer shell. Kailangan kasi, meron kasi tayong tinatawag na octet rule, ma'am, di ba? Okay. To attain stability, an atom's outermost shell,
kailangan magkaroon siya ng 8 electrons.
Oo, yes. 8 valence electrons. Unless hindi siya stable. Kapag hindi stable ang isang atom, maghahanap yan ng ka-pair niya.
Yes.
Diba? Oo.
Ay, sana all.
Stable ka na ba, ma'am?
Yes,
Hindi
ma'am.
na. So, na-apply mo ang octet rule.
Oo, syempre, diba? Hindi lang, diba kasi dito sa octet rule, hindi lang iisa yung makikinabang diba?
You both complement each
yes.
other.
Kung mababawasan yung isa, madadagdagan yung isa, hindi ibig sabihin na, yung isa na nabawasan dyan, nabawasan siya. Kumbaga parang hindi na siya, anong tawag nito, parang may kulang na sa kanya, hindi. Nagsisharean sila, nagpapahingian sila ng kanilang mga electrons to attain a stable configuration. At yun naman yung diba, sa chemical bonding, Ma'am Jen, kailangan lahat ng natin is, they have to attain a stable configuration.
Yes, pwedeng sabi dyan to follow the electron configuration of the noble gases. Yes, so pero si special lang kay hydrogen kasi okay na sa kanya yung 2 valence electron. Hindi niya kailangang magkaroon ng 8. Yan. So, special diba, si hydrogen.
Sabi nga natin, di ba?
Kasi ifa-follow niya yung katapat niya na si helium.
Yes. Oo. Parang, di ba, in every rule, there is always an exemption.
Okay. So, we have the Lewis dot structure. So, makikita nyo dyan yung position ng dots doon sa mga mga atoms. So the dots represent the electrons or at the outermost shell, or we call that the valence electron. So si hydrogen, si lithium and sodium, dahil nandun sila sa family number 1, so meron silang 1 na
valence electron.
Yes.
Ang ano dyan, Ma'am Jen, is kung anong group siya, yun na din yung kanyang valence electron.
Yes po.
Oo.
Okay, so tignan nga natin halimbawa si carbon. Carbon ay merong ilang valence electron.
There are 4, Ma'am Jen.
Yes. At dahil kapamilya niya si silicon, pareho silang may 4 valence electron.
So, ibig sabihin, Ma'am Jen, nasa group 4A din siya sa periodic table natin. So, madali lang, di ba? Mag-determine ng valence electron for the representative elements. Di ba?
Opo.
Kasi kung ano yung kanilang group number, yun na din yung kanilang valence electron.
Yes. Okay. Then,
Next.
always remember, atoms are trying to complete their valence shell. Ayun yung tinatawag nating octet rule. 2 will do, that's for hydrogen, but 8 is great.
Yes, of course.
The number of electrons the atoms need is the total number of bonds they can make. Halimbawa, balikan nga natin si hydrogen. Dahil may isa siyang valence electron, pwede siyang magkaroon ng 1 bond. Yan. Then, si carbon, meron siyang 4. So, 4 bonds ang pwede niyang magawa. Okay, yan o. Example, hydrogen. So, si nitrogen, pwede siyang may 3. Si oxygen ay 2.
Fluorine.
Okay. Ayan. So, ganito ma'am, di ba, kung paano mag-draw ng Lewis dot structure. You may represent valence electrons from different atoms with the following symbols. Okay, pwedeng dot, pwede rin X.
Yes, ma'am.
Oo. Minsan ginagamit natin ng X eh.
Pero sa akin, ang ginagamit ko lang yung dot.
Okay.
Dot lang yung ginagamit ko sa pag nagklaklase ako, Ma'am Jen. Hindi ko pa sinubukang gumamit ng X. Kasi yung X, mali eh. Parang X. Oy, hindi pwede. So, dapat dot na lang.
May negative siya kagad pag X.
Oo, X kasi.
Ay, ako kasi minsan, ang ginagamit ko ay X kasi mas madali siyang makita kaysa sa dot. Oo. Saka mas madali siyang isulat. Minsan kasi yung chalk ayaw sumulat doon sa ganyan-ganyan mo, hindi makita. Oo.
Pero minsan kasi gumagamit kami ng yung colored chalk.
Wow, social.
Social. Mga sosyalin, di ba?
Oo, yan.
Okay. So, dito sa, ma'am, sa Lewis dot structure, meron ka bang dapat na i-follow kung saan ka dapat mag-umpisang maglagay ng mga dots or ng X?
Okay. Parang pwedeng wala, pwedeng meron.
Yes. Kung meron.
Hindi,
gusto
pero
mo maayos,
meron pala talaga. Yes.
Pero hindi lang natin kailangan dito ka muna sa taas mag-umpisa.
Actually, pwedeng hindi.
Pwedeng hindi. Kahit saan ka mag-umpisa, as long as tama yung yung number of electrons na ilalagay mo at nasa ayos, of course. Kasi minsan din ang ginagawa ko is, Ma'am Jen, kailangan, di ba, sharing and transfer of electron, di ba? Para mas madali na ipakita sa kanila, sa mga estudyante ko yung inaayos ko na.
Yes, oo. Para makita yung bands.
Yes,
kasi pwede tayong single, double, triple. Ayan. Yung next week naman na lesson natin yan.
Yes, Ma'am Jen.
Okay. So, covalent bonding. Nasabi na kanina.
Nasabi na natin.
Ito yung sinasabi ni ma'am na kailangan maayos para makita yung bonding.
Makita, yes. Kasi pag magulo yan, Ma'am Jen, ay hindi rin tayo magkakaintindihan.
Yes. Okay, so this is a finished Lewis dot structure. Every atom has a filled valence shell. So si carbon kanina, 'di ba, meron siyang 4 lang ang kanyang valence electron. So kailangan pa niya ng 4. And so hydrogen is readily available with 1 valence electron. Therefore, carbon needs 4 hydrogen atoms to complete its valence shell.
Para maging stable siya.
Oo.
To attain the stable configuration.
Ayan. Ito dito sa first, sa upper illustration natin, dots ang ginamit, ano? So, kung bibilangin mo yung dot, kailangan maging 8 yan para maging stable silang dalawa. Okay? Okay, 8. Si carbon, kailangan may 8. So, ibilangin mo yung nakasurround sa kanya. So, 1, 2, 3, 4, 5, 6, 7, 8. Yes. Si hydrogen naman, okay na sa kanya yung 2.
dalawa. Kaya,
So, yung nakatapat sa kanya, 1, 2. O si another hydrogen is 1, 2. Another hydrogen, 1, 2. And the other one also. Yan. So, ganun siya, no? Or, pwede rin isulat na 1 straight line. That represents the bond that exists between the atoms. So, si carbon, then may hydrogen sa paligid niya, then meron lines na nagko-connect sa kanila. So, yung 4 lines there means 4 bonds.
Yes. Yes, Ma'am Jen. So, paano natin nakuha yan, Ma'am Jen? Or how did we get here? Paano natin nabuo yan yung ano nito ng Lewis dot structure na ito?
Okay. So, ma'am, okay. Bigay mo na ang ating general rules.
Okay, so eto kung paano nabuo yung ano natin kanina, yung CH4 or yung methane. Okay, so we have here the general rules for drawing Lewis structures. Number 1, all valence electrons of the atoms in Lewis structures must be shown. Siyempre, di ba, hindi mo kailangan magtago yan ng isang, baka mamaya magtago ka ng isang dot dyan, Ma'am Jen. Kukulangin tayo pag ganun, di ba? Okay, next. Generally, each atom needs 8 electrons in its valence shell except hydrogen na dalawa lang yung kailangan niya. And of course, yung boron. Need lang niya ng 6. Okay, multiple bonds, double and triple bonds can be formed by carbon, nitrogen, oxygen, phosphorus, and we have sulfur. Central atoms have the most unpaired electrons. Dapat siya yung nasa gitna. Yung mas maraming
Yes, ma'am.
walang
Parang
kapartner.
kanina,
Yes.
yung carbon.
Oo.
Siya yung...
Nag-iisa.
Oo. And siya yung mas maraming kailangan.
Alangan naman, ma'am, di ba?
Siya yung nasa gitna.
Yes, siya yung nasa gitna. Kumbaga, parang pag ano yan, alangan naman na parang ano, paano ba ito? Paano ko i-connect? Nakalimutan ko na yata,
Hihayaan
Ma'am
mo
Jen.
yun.
Oo. Balikan ko na lang mamaya. Okay, terminal atoms have the fewest unpaired electrons. Yung terminal atoms, yun yung mga nasa labas. Yung nakasurround doon sa central atoms. Okay. So, ito yung mga examples. Okay. So, when carbon is one of few atoms, it will always be in the center. Yung kanina dun sa previous slide natin, sometimes you only have 2 atoms, so there is no central atom. Siyempre naman, di ba? Okay, we will use a method called the ANS. Ano yung ANS natin? Available, the needed, and the shared to help us draw our Lewis dot structures for molecules. Okay, so isa-isahin natin yon. There are actually, ilang steps ito, Ma'am Jen? Parang 5 yata or 4. Okay, so an example, write the Lewis structure of H2O. Ano na ba yung H2O? Ito yung water where oxygen is the central atom. Bakit oxygen yung naging central atom natin? Kasi siya lang yung nag-iisa. Kaya di ba may nakikita tayo na 2 doon sa tabi ni hydrogen? Ibig sabihin, there are 2 atoms of hydrogen. 2 hydrogen ang kailangan. Okay, so step number 1. Hindi siya nakita. Determine the total number of electrons available for bonding. Because only valence electrons are involved in bonding, we need to determine the total number of valence electrons. Okay, so yung hydrogen natin, since we have 2 atoms of hydrogen, nasa group 1 siya, so ibig sabihin, isa lang yung kanyang electron. So, 2 times 1, we have 2. Tama ba ako, Ma'am Jen?
Yes.
Okay, so ang available electrons ni hydrogen is 2. Then for oxygen, nasa group 6 siya. So meron din siyang available na 6 electrons. So, all in all, we have 8 electrons. So, there are 8 electrons available for bonding. Okay, step number 2. Determine the number of electrons needed by each atom to fill its valence electron. So, needed valence electron. So, 2 sa hydrogen, kailangan niya ng 2. So, there are 2 atoms of hydrogen. So, tigda 2 siya. Kailangan niya ng 2. So, 2 times 2, we have 4. Then, for oxygen, it needs 8. So, there are, ilan? 4 plus 8, there are 12 electrons needed. Nasusundan po ba natin? I hope so. At andyan pa rin kayo na nakikinig. Okay, step number 3, Ma'am Jen. More electrons are needed than or there are available. Atoms therefore make bonds by sharing electrons. 2 electrons are shared per bond. So, shared 2 electrons per bond. So, eto siya kung paano. Number of bonds is equal to the number of electrons needed. Ilan ba yung kailangan natin kanina dun sa previous slide natin? And then, minus the number of electrons available divided by 2. So, we have 12 needed and available. We have 12 minus 8 yung available kasi 8 lang yung available niya, di ba? Divided by 2, we have 12 minus 8 is 4. Divided by 2, we have 2 bonds. So, draw oxygen as the central atom. Draw the hydrogen atoms on either side of the oxygen atom. Draw the 2 bonds that can be formed to connect the atom. So, andyan na sa screen natin. Nakikita natin, di ba? Yung oxygen is our central atom. Okay, then hydrogen, sila yung terminal. Sila yung nasa labas. So, parang, anong nangyari dito? So, naging complete na si oxygen. Tama? Nagkaroon na siya ng ilang electrons, Ma'am Jen, yung si oxygen? Naging 8 na siya, kompleto na siya. Then hydrogen, meron na siyang tigda 2. So parehas na silang stable. Okay, number 4. Use remaining available electrons to fill valence shells for each atom. All atoms need 8 electrons to fill their valence shell, except hydrogen needs only 2 electrons to fill its valence shell, and boron only needs 6. So for water, there are 2 bonds and 2 electrons per bond. So nandyan na nakikita natin. So number of available electrons remaining is equal to the number of electrons available minus the number of electrons shared. Yun na yung kailangan natin. So we have 4 extra electrons. Okay, so sometimes multiple bonds must be formed to get the numbers of electrons to work out. So, ito yung double bond, triple bond. So, pag double bond, they share 2 electron pairs. So, parang 4 na electron yon. Pag triple bond naman, 6 electrons, 3 pairs. Okay, kagaya ng oxygen gas dun sa double bond, then sa triple bond, nitrogen gas. Yung example number 2 naman natin, Ma'am Jen. Okay, so we have CHO. Available valence electrons, yung step 1 natin, si carbon. Group 14 siya. Ang available na electron niya is 4. Then, hydrogen, nasa group 1, 2, ang kanyang available. Oxygen, 6 yung kanyang available electrons. So, all in all, we have 12 electrons available for bonding. Then, step 2, yung needed valence electrons natin. Ilan yung kailangan niya? 8, 4, 8. So, we have
20. Okay, so there are 20 electrons needed. Then, yan. Step number 3. So, we have 2 electrons per bond. Ayan. Number of bonds equals N needed minus A which are available divided by 2. So 20 minus 12 divided by 2 is 4 bonds. Okay, so draw the carbon as the central atom. Ayan. Draw the hydrogen atoms and oxygen atom around the carbon atom. Draw 2 bonds of the 4 bonds that can be formed to connect the hydrogen atoms. Kasi nga, si hydrogen, kailangan niya lang 2. So, draw the remaining 2 bonds to connect the oxygen atom. So, oxygen can form double bonds. Yes. Step number 4, use remaining available electrons to fill valence shell for each atom. Ayan. So, pakita mo na yung iba pang valence electron ng, ayan, halimbawa, so, si oxygen, so, yun, nagpakita na yung another 4 valence electrons niya. So, nagkaroon na siya ng total ng 8. Kung inyong bibilangin, so, 1, 2, 3, 4, and then yung double bond is 2 pairs of 4. Yan. Kaya 8 na siya. So, si carbon, meron din siyang another may 4 bonds siya, which is a total of 8 electrons. Then, the hydrogen, total of 2 electrons. Ayan. So, eto na ba yun?
So, yun naman, Jen. Okay, so...
Okay, lampasan na natin to.
So, susunod na dito, Ma'am Jen, yung the different properties. Tama ba ako, Ma'am Jen? The different properties of compounds.
Okay, pakita na lang natin ito, ma'am. Itong
Yes,
itsura
yung mga
ng...
examples.
Ito, ayan. Yung itsura ng polar molecules, merong unequal sharing of electrons. Ayan. So, hindi equal yung sharing. Then, non-polar molecule, ayan, equal ang kanyang sharing ng electrons. Si polar molecule, na another one, yan, not symmetrical. Non-polar molecule, symmetrical. Okay, so yun.
Liwanag naman dyan sa mga illustrations.
Oo, lampasan na lang po natin to para mas mabilis. Anyway, na-discuss na kanina. So, yes. Ha? Ay, balik na. Okay, dito na. Saan tayo?
Okay, so si Sir Ronnie, yes. Andito na po si Sir Ronnie to discuss to us the different properties of compounds. Okay, Sir Ronnie.
Okay, good afternoon po sa ating lahat. So, napakaganda discussion natin about sharing and giving of electrons, the ionic compound and the covalent compound. Now, let's proceed to the properties of covalent. So, we will discuss first the properties of ionic compound. So, let's review the definition of ionic compound. When we're talking about ionic compound is a compound that is formed by ionic bonding. Ionic bonding occurs through the process of electron transfer. So, where one atom gives electrons to another, that's why nagkakaroon tayo ng positive and negative charges. So, kaya meron tayong positive at negative because of this ionic or transfer of electrons. So what are the properties of ionic compound? So, hati natin yan. So, we have first the physical properties of ionic compound. So, pag physical, ano bang masasabi natin sa ionic compounds? Ionic compounds are solid and hard to break due to the strong force of attraction. So, malakas yung attraction between the elements doon sa ionic compounds. That's why mahirap silang ma-break o mostly hard sila, solid sila. However, they break into pieces when pressure is applied, so they are considered brittle. Pero yun nga, pag merong pressure na after ng pressure, nabe-break o nahati rin naman sila. So how about the melting and the boiling point of ionic compounds? A large amount of energy is required to break the ionic compounds between the atoms. Matanda na yun, sinabi natin kanina, because of the strong force of attractions doon sa between the atoms, nangangailangan naman ng mas mataas na energy to break yung ionic band. So, ano nagiging result? Ang nagiging result na yon, ang lahat ng ionic compounds ay mayroong high melting and boiling point. So, mataas yung melting point nila at yung boiling point nila. How about the solubility of ionic compounds? So, pag solubility, natutunaw, ganun yan. So, ionic compounds are generally soluble in polar solvent. Ano yung mga polar solvent? Ito yung katulad ng water. But, solubility tends to decrease in a non-polar solvent. Ano may mga non-polar solvent natin? Petrol, gasoline, yan yung matatawag nating non-polar solvent. How about the conduction of electricity? Ano ba ang mga ionic compounds? Good conductor ba or poor conductor ba ng electricity? So although ionic compounds do not conduct electricity in solid state because movement of ions is not possible, but they are good conductors in a molten states because electrostatic force of attraction between the ions are overcome by the heat release. Pero generally, kapag pinag-usapan natin ang ionic compounds, they do not conduct electricity in a solid state. So yun yung properties ng ionic compound. How about the covalent compounds? So, kanina yung sinabi nila Ma'am Dina, when we're talking about covalent compounds, kung yung isa kanina willing magbigay ng electrons yung sa ionic compound, ito naman, when we're talking about covalent compounds, or the covalent compounds are characterized by the covalent bonds. Or covalent bonds are characterized by sharing of electrons between two or more atoms. So, ito naman, sharing. O ba, pinagsisharean nila yung electrons. These bonds mostly occur between non-metals or between two of the same element. So, basta para sila, mostly nangyayari ito sa mga non-metals. Two atoms with similar electronegativity will not exchange an electron from their outermost shell. The atoms instead shared electrons, so their valence electrons shell is filled. So what are the characteristics of properties of covalent bonds? Number 1, low melting and boiling points of covalent compounds. A relatively small amount of energy is required to overcome the weak attraction between the covalent molecules. Kung kanina, mataas yung melting point and boiling point ng ionic, ito naman, mababa yung melting point at boiling point niya. The reason is the weak attraction between the covalent molecules. Next, low enthalpies of fusion and vaporization. This property is usually one of the two orders of magnitude is smaller than they are for ionic compounds. Next, covalent compounds are soft or brittle in solid form. The weak intermolecular forces makes the solid form of covalent molecular compounds too easy to distort or break. So yung force nila, ang nagiging reason ba't sila nagiging soft or brittle, yung weak intermolecular forces ng covalent compound. Next, poor electrical and thermal conductivity. Ionic compounds conduct electricity well when melted. Tatandaan natin yung ion compounds kapag melted yung pero pag solid sila kanina, mapapansin nyo ay poor conductor sila ng electricity. Metallic solids do as well. Covalent molecules compounds do not. So, ang covalent molecules naman, hindi sila nagkakandak ng poor conductor sila ng electrical and thermal or heat and electricity. Pero ionic compounds kanina, poor lang sila kapag nasa solid state. Pero once na sa ionic compound sila or natunaw na sila, they are good conductor of electricity. These are the examples. Yes, Ma'am Dina?
Yes, Sir Ronnie. Pinakita lang natin yung yung sa slide na ito. Ma'am, ibalik mo. To sum up yung sinabi ni Sir Ronnie, dear learners, eto siya. The comparison of the properties of the ionic and the covalent compounds. So makikita nyo na diyan yung summary, yung sinabi ni Sir Ronnie. So Sir Ronnie, thank you. Okay, so next naman natin, di ba, sabi namin kanina ni Ma'am Jen, compounds are everywhere. Ang dami-daming mga compounds na nakikita, ginagamit natin. So, ano ba yung mga, what are these compounds? Ano yung mga compounds na ito? At ano yung mga gamit nila? Okay, the uses. Kasi yung mga ano na ito, they are being used in the industrial, pwede rin in the field of medicine. Saan pa ba? In the field of medicine, lahat-lahat compounds ay ginagamit natin. So,
Sa pagluluto.
yes, sa pagluluto, yung ano na lang, Ma'am Jan, di ba? Yung asin. Yung asin na nga lang, di ba? Napaka-importante yung asin eh. Or yung table salt or the sodium chloride. Di ba? Okay, so, let us welcome Ma'am Donna to give us more examples of ionic and covalent compounds and their uses. So, Ma'am Donna.
Mukhang hindi nakapasok si Ma'am Donna, ma'am.
Hindi ba nakapasok si Ma'am Donna?
Yes, ma'am. Mukhang hindi
okay,
siya nakapasok at room.
So, can you do the honor, sir, to continue na lang the different
Sige.
compounds used?
Tignan natin to, ma'am,
Yes.
kan, kung ano saan na ginagamit. Tignan natin isa-isa. So, the uses of ionic compounds and covalent compounds in our daily lives. So, most of the...
Ionic compounds.
Wait lang, wala pala sa PowerPoint natin yun na isa kanina.
Wala, sir. Sa ano na lang. Hindi mo
This is good
na-download,
talaga.
sir.
Yes. Most ionic compounds and covalent compounds used in our daily lives are in industrial sector, agriculture, medicine, and domestic use. Kapag pinag-uusapan natin, Ma'am Dines and Ma'am Jen, ang industrial sector, ano yung mga example, kung may example ng ionic or covalent compound na ginagamit doon sa industrial sector? Ma'am Dines, ano yung mga compounds
Yes, sir. An
doon?
example,
Ano yung mga...
yes, sir. An example is yung battery or the
Yes,
lithium iodide.
Okay.
Ginagamit.
Lithium iodide, example of ionic compound. Tama, ma'am? The
Yes,
lithium
sir.
Yes,
iodide?
sir. Yes.
Yes. How about yung paint? Ma'am Chen.
Yes, paint contains covalent compounds such as pigment and turpentine solvent, Sir Ronnie. So, covalent
Okay.
compound yung paint.
So, yun yung example sa industrial sector.
Of course, marami pang iba dyan, Sir
At
Ronnie.
marami
diba?
pang.
Oo,
Yes,
marami
ma'am.
pang.
Sa marami pa dyan. Pero sa agriculture na tayo, pumili na tayo, mas common. Ito common talaga.
Yes, kasi
Ionic
mga
compound
farmer.
of ammonium nitrate. Ang ginagamit ammonium nitrate, potassium chloride. Ang ginagamit yan, ma'am?
Sa
Pag
bukid.
agriculture,
Sa bukid, sir.
sa bukid,
Oo.
fertilizer. Tama, ma'am?
Yes, yes, sir.
Mga fertilizer. Samantalang yung pesticides used to kill weeds and insects contain covalent compounds such as ano yung mga pesticide, ma'am, na may contain ng covalent compound?
So, we have bromoethane and chloropiscrine.
Yung mga pesticides.
Those are-
Chloropiscrine. Yes, mga pesticides na napakalaking tulong sa ating agricultural sector.
Ma'am, tulong pa ba yon? Tulong pa ba?
Pero ano na siya,
Parang
hindi na gaanong tulong kasi minsan nakakapag-produce pa siya lalo ng
Oo.
harm sa
Yes,
environment.
Sa
So we
environment, sa
go
tao.
for the organic pesticides.
Hindi
Pero covalent
About-
compound pa rin
Yes,
yung mga
oo,
yun,
yes.
mga pesticides.
Yes. How about in medicine, ma'am?
Okay, in the medical sector, meron tayong mga, yan, yung mga gamot natin na nagkakaubusan na ngayon.
Kagaya ng paracetamol, ma'am. Nako.
Okay, so ito, sodium bicarbonate, antacid. Ito, pag masakit ang tiyan mo at ikaw ay hindi makautot, kailangan mo to. Yan, sorry for the word, sodium bicarbonate ang kailangan mo, which is an antacid. Okay, then,
Okay, ionic compound yun.
ionic
ma'am, tama?
compound yon. Oo. Then, covalent compound, yan, mga biogesic, paracetamol, yan, used to treat fevers and irritation, pwede ring body pains.
Yes, mga pain
Okay, generally,
relievers.
paracetamol, biogesic, paracetamol yun.
Yung ngayon, sir, yung mga yun, sir, parang balita ko, nagkakaubusan na daw eh. Totoo kayang
Yes,
nauubos
ma'am, ang hirap.
or tinatago lang?
Tinatago. Ang hirap bumili na yan ngayon.
Oo, tama
Marami
ka,
na
sir.
kasing ngayon, nangangailangan. Ano? So, meron din tayong sa domestic use. Ito,
Gamit ni nanay.
gamit ni nanay at ni tatay din, syempre.
Oo, si tatay din. Sa Ronnie, di ba?
Oo.
Gamit ni nanay,
Yes.
at gamit ni tatay yan.
Oo.
Kagaya ng...
Yan. Detergents contain the ionic compound sodium chlorate. Yan, which is used for domestic cleaning.
Naba.
Then, we also have glycerol. It's a covalent compound added to skincare products to moisturize skin and help to prevent dry skin.
Yes.
Oo
Mga
na.
pinapahid-bahid ba yan, ma'am Jen?
Oo, glycerol. Nasa mga beauty products. Okay, so yun na yung end ng ating slide, Ma'am Dina.
Yes, Ma'am Jen. So, hopefully marami silang natutunan. O, para hindi natin makalimutan.
And
eto yung
marami
mga-
pang iba, katulad
Yes.
na marami pang iba.
Marami pang mga ibang mga compounds nagkalat. Okay? So, to sum up, or yung mga takeaways natin for today's, this afternoon live discussion, we have, anuhin lang natin, i-recall natin summary. Okay, so unahin natin dun sa pag-identify whether, how to identify, parang ganun, whether an element is a metal, non-metal, or a metalloids. So the heavy zigzag line running diagonally from the upper left to the lower right through groups 13 to 16 divides the elements into metals and non-metal elements, non-metals. And non-metal elements that lie along the diagonal line exhibit properties intermediate between metals and non-metals. They are called the semi-metals, or yung tinatawag natin na mga metalloids. Okay, we have also discussed electronegativity difference to help us determine the type of compound. So, pag yung electronegativity difference natin is greater than 2 or greater than 2 ba yun, Ma'am Jen? 2 pataas, then it is an ionic compound or ionic band. Okay, pag kanyang electronegativity difference is from 0.021 to 1.99, that is polar covalent. And then, the last one, pag 0 to 2 or 0 to 0.02. 20. Yes,
Point 2.
point 2. Yes, point 2. That is a non-polar covalent bond. Okay, another is, of course, the different properties of compounds, or the different types of compounds can be recognized based on their properties, such as the melting point, hardness, the polarity, and electrical and thermal conductivity. And the last but not the least, the uses of ionic and covalent compounds in our daily lives. So marami, yung mga binigay namin na examples kanina, konti lang ang mga yon. Baga parang isang ano lang yon. There are lots of chemical compounds, Ma'am Jen. Okay, so Ma'am Jen, dyan na po
Ayan.
nagtatapos.
So, dyan na po nagtatapos ang ating lesson for this week. Mga anak, huwag kakalimutang basahin ng maigi, sagutan ng mga activities, and syempre huwag kakalimutan ang ating validating question, performance task, and your reflection.
Yes.
Okay, ayusin ang pagkasasama-sama ng mga papel para hindi malito si advisor sa pagdidistribute sa mga subject teachers.
So, huwag niyong kakalimutan isulat ang inyong mga pangalan. Tama. Then, isa pa, Ma'am Jen, yung
Section din.
Yes, yung ginagawa nila na pinagsama-sama yung lahat ng subject sa isang papel, yung kanilang sama thesis.
Ang galing nila, no? Nagawa nila yon.
Pero mga anak, hindi dapat yun kasi iba-iba naman yung mga teachers ninyo.
Sa iba-ibang tao mga pupunta ang mga yon para kanilang i-check at i-record. Ayan, so maraming salamat sa ating mga learners, sa ating mga grade 9 learners sa pakikinig sa ating talakayan for this afternoon. Maraming salamat sa mga nag-tune in sa ating Facebook Live at sa mga nakikinig sa radyo. Ayan, mag-ingat po tayo palagi and God bless us all.
Okay, so
see you next week.
Yes, maraming salamat din sa ating technical specialist.
Na nandito,
Yes,
Sir Joshel.
nag-iisa.
Thank you very much sa support.
Yes. Sa lahat ng mga nasa
Work from home ba?
work from
Sa
home
bahay?
ba? Yung lahat ng nakasama dito sa natin ngayon, discussion natin. Maraming salamat po.
Sir Ronnie and
Yes.
Ma'am Donna, thank you. Yes. Okay, goodbye.
Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is the way of helping the brain grow in finding new knowledge and help us defeat our curiosity in how the world develops and works today. Science. This is your class, and this is Science. And now, here is your host for the day. Ito ang 106.3 Dance Radio. Dance Radio.
Prepare yourself.
Ang silid-aralan sa radyo, hatid namin ay makabagong paraan ng pagtuturo at kalaman. Mapaumaga, tanghali o hapon man yan. Ang istasyong magbibigay impormasyon kahit saan man.
For something big. Alright, here we go.
106.3 Dance Radio. Doña Aurora National High School, Santa Rita, Aurora, Isabela.
This
106.3 DWDR FM.